question is, differentiate 1 sine of 3x squared, 2 the square root of cos of 2x, and 3 x cubed cos of 1 on x. What are the domains of the functions in 2 and 3? Alright, 1 in Roman numerals, y equals sine of 3x squared. Alright, well I've got a 3x inside a sine, so that means I need to use the chain rule. So dy on dx. So I'll do the derivative of the sine, which is cos, pretending that the 3x squared is just like a blob, that I can pretend it's just an x. And then I can put my 3x squared back in there, and then I need to do the derivative of that, which would be 6x. So my derivative is 6x cos of 3x squared. Okay, number 2. Number 2, y is the square root of cos of 2x. So this time I have 3 functions inside each other. I have a square root, and then I have a cos, and then I have a 2x. The chain rule works the same way, I just work from the outside in. So dy on dx is equal to, maybe I'll just rewrite that square root as a power of a half first. That's better. Okay, so dy on dx is half of all that to the minus a half. And the thing inside there is cos 2x. And then I move back into those brackets and I do the derivative of what's in there. So the derivative of that would be minus sine of that. So let's move in again. I've got 2x. And then I have to do the derivative of what's inside there, which is the derivative of that is 2. So let's see what we've got. We've got a minus here, so minus half times 2 gives me 1. So I've got a cos 2x to the minus a half, which is actually 1 on the square root of cos 2x. And I've got a sine 2x on the top. So that's my derivative this time. Now I've been also asked to find the domain of my original function, y equals the square root of cos 2x. So let's have a look at where that's defined. I'll start a new page to do that, I think. Y is defined when the thing under that square root is positive. So y is defined when cos of 2x is greater than or equal to 0. It could be equal to 0 because you can do square root of 0. Okay, so we ask ourselves, when is cos of 2x positive? And that would be when 2x is in a certain region around that unit circle. So here's our unit circle. Cos is positive here. So that means 2x is between minus pi on 2 and pi on 2. Only, of course, if I went round another 2 pi, or any multiple of 2 pi, I'd be in the same place again, and so cos of 2x would still be positive. So I should add on some multiples of 2 pi, so 2 pi k and a 2 pi k here for k an integer. So k is in z. Alright, so I can divide everything by 2 to get my x, so I get pi k minus pi on 4 is less than or equal to x, which is less than or equal to pi k plus pi on 4. I'm just going to draw a picture of what that looks like. So here's 0 pi here, plus pi on 4 is there, minus pi on 4 is there, so we have this bit. And here's 1 pi here, minus pi on 4 is here, plus pi on 4 is here, so x needs to be in there. And that's where we have it, but of course any multiple of 2 pi around there will get you the same spot. So I think we can now state our domain. So domain of y is the set of x in R such that pi k minus pi on 4 is less than or equal to x, which is less than or equal to pi k. Whoops. Pi k plus pi on 4 for some k in z. Close my curly brackets. Now I know that doesn't look like a particularly nice set description, but I don't think I can write it particularly easily as just a union of various intervals because there's infinitely many of them. So I think it's best to leave it like that. Fix my in sign. Okay. Well, let's do the next page. So we're up to the third one. Y equals x cubed cos of 1 on x. Okay, so dy on dx would be equal to what? Well, we've got two things multiplied together here, so we have to use the product rule. So we'll do the derivative of the first one, 3x squared, but we won't change the second one, cos 1 on x, plus the first one without changing it, and then we'll do the derivative of the second one, the derivative of cos 1 on x. Well, I have to use the chain rule for that one, so it'll be the derivative of cos, which is minus sine of that, and the thing in there is 1 on x, and then I need to do the derivative of 1 on x, because that's what's inside the brackets. Okay, let me just rewrite it up here so that I can keep track in my mind. 1 on x is really x to the minus 1. So the derivative of x to the minus 1 is minus 1x to the minus 2, because we bring the power down in the front and we reduce the power by 1. Okay, so now I've got this, I can simplify it a little. 3x squared cos 1 on x plus, let's see, we've got 2 minuses there, so they cancel out, so it really is a plus. X cubed times x to the minus 2, so we'd add the powers, that'd just be x, and we're left with our sine 1 on x. So there's the answer for the derivative. Now the question also asks me to find the domain of my original function. So let's see, well, x cubed is always defined. Cos is defined on any real number, so we're really interested in whether 1 on x is defined. So let me just write that down. Cos 1 on x is defined for all values of 1 on x. 1 on x is defined for x not equal to 0. So the domain of y is everything except 0, so the real numbers without 0. And that's the end of the question.